Hello and welcome back to the conference. I hope you had some rest and you're ready for the final sessions, the two final sessions of this workshop. We will start with the Island of Rhodes. This is a joint paper prepared by Sofia Sotiropoulou of the Institute of Electronic Structure and Laser of the 4th, Crete, and by Tula Marketou from the F48 of Antiquities of the Dodecanese. And they are going to, I think it's going to be presented by Sofia Sotiropoulou, who's going to talk on Rhodian purple dye. So please.
Thank you. And first of all, I'd like to sincerely thank the organizers, both Cretan and Cypriot, for the invitation and for all the organization and communication before the workshop. Unfortunately, Tula Marketou could not be here, so I'll present the paper myself. Triada, the major prehistoric settlement of the Dodecanese, is situated in the wider area of Ialissos, originally near the coastline, now shifted up at a distance of 500 meters on the inland side. The landscape was bordered by streams descending from Mount Philerimos to the sea, forming deltas. It seems most probable that the larger branch of the main stream, now known as Stream of Triada, was navigable to the ships sailing across Asia Minor from the eastern Mediterranean and Crete. During the late Bronze Age 1A, the settlement was one of the great urban centers in the Aegean, which with at least 4 wide stone-paved streets, ashlar buildings with more than 1 stories, including luxurious apartments with rooms with pier and door partitions. The impressive building complexes were plastered in the interior and at least in one case in the exterior, most probably for protection from humidity. Fragments of frescoes on fine plasters were found in almost all the excavated buildings. The majority of the frescoes were found fallen and removed in secondary deposits within the debris from the devastating pre-eruption earthquake in 1630-1610, according to the high chronology. Many fragments belong to the decoration of the upper zone of the walls, with parallel reddish horizontal bands or bright blue bands painted with Egyptian blue, and in some cases with running spirals and elaborated elegant rosettes. Dados imitating veined marble, similar to examples at Acroterion Thera, decorated the lower zone of the walls. The floors were covered with fine and strong plaster decorated with small red, blue, orange, grey, or black splashes, imitating pebbles or agglomerated motifs. The reserved space between the upper zone and the dados was covered with several scenes, often inspired from the natural environment, such as liliums, foliate bands, and the reeds similar to those on the banks of the streams. Other scenes in the main decorative zone of the walls display costumes of women figures or religious scenes. Emblematic pictures of Nilotic scenes and acrobats performing parallel to papyri derived from a tripod offering table made of plaster and are indicative of the high level of painting in the late Bronze Age 1A Rhodes. Several red, pink, brown, and yellow natural mineral pigment lamps have been found among pottery and other finds during the excavations at Triada, the majority of which were used for the wall or floor paintings. However, the most intriguing find of this kind was a quantity of purple pigment found at the excavation of Paraskeva's plot in the southwest sector of the Late Bronze Age settlement, east of the Great Triada stream. The pigment was found in the depth of 3 meters, 0.40, below the surface of the modern street, within a layer of debris thrown in the northeastern open-air space, outside of a monumental building, Axeste, similar to the Axeste at Acrotirion Thera. The valuable find was found together with lead weight, with an incised circle in the center, a crucible for melting copper, a fragment of fresco depicting a rosette, other fragmentary frescoes, a whitish powder, and a piece of mineral, while according to the stratigraphy it belongs to a clear late Bronze Age 1A stratum. It was found just beneath a small fragment of fresco depicting an elaborate black running spiral on a shiny whitish ground, among other fragmentary monochrome dark grey, reddish, orange or whitish frescoes, pieces also of round tripod offering tables made of lime plaster, a reddish schist stone slab, along with fragments of conical or some semi-globular cups and saucers, painted late Bronze Age 1A pottery, as well as animal teeth and bones. The context comprises a secondary deposition of several materials fallen among the pre-eruption earthquake ruins, which were removed outside the ruined building in order to clean it and prepare its reconstruction. Similar contexts appear very often in the LBA-1A layers, mostly in the exterior of buildings, and they are indicative of intensive cleaning activities of the earthquake ruins at Triada before the Tefra fall. The pigment has the appearance of a cohesive dry mass, most probably once kept in a container of perishable material. Selecting bits of purple color from the mass of the find under microscope, the pigment presents a vivid cold purple color and a relatively homogeneous fine texture. As purple dyed fabrics are unlikely to be found due to the perishable nature of the organic substrate, purple pigment finds, as the Triada case, become a valuable trace of purple dyeing industry. The topic of Tyrian purple, or more correctly saying selfish purple, which is a more appropriate descriptor since the distribution of purple-producing snails is worldwide, is attractive not only for its archaeological and historical importance, it is equally challenging and fascinating for the analytical chemistry point of view, for understanding how the dye is produced from mollusks, what is the dyeing procedure, what is the mollusk species employed for its extraction, as identifying the biological source may give a hint relating to the provenance of the dyed textile or the pigment, or more generally the industry of its production. And finally, what is the most appropriate analytical protocol for identifying the exact composition of the dye or pigment, and whether this analytical information is sufficient to answer the mentioned archaeological queries. The composition of and the chemistry involved in the selfish purple production has only been achieved as a result of advanced analytical studies in the 20th century. The literature is exceptionally rich, but still some issues remain open for further investigation. Selfish purple comes from the marine mollusks of the Muristidae family we have already discussed about. Among the three species living in the Mediterranean basin, in the Aegean Sea, Trunculus is the most abundant, followed by Brandaris and Stramonita mastoma. The coloring compounds of the purple do not exist in the living mollusks, but they are produced by precursors that are called chromogens. The chromogens are present in the hypobranchial glands of the mollusks and undergo spontaneous chemical reactions under exposure to light and air, thus yielding the coloring components of the shellfish purple. This is the direct dyeing method. The color changes observed on exposure of the glands of Murex trunculus and Murex brandaris to sunlight have been noted already in the 17th century. This is the picture. Both are initially yellow and then change to green, then blue, and finally purple for the trunculus and a reddish purple for the brandaris. In the vat dyeing process, the chemical procedure is much more complex than in the direct dyeing. The colored water-insoluble extract from the glands must be chemically reduced in the dye vat to give the water-soluble and colorless leucoforms of the compounds. Reduction is induced by bacteria according to the mechanism that has been first understood for the reduction of the oud, for the indigo. The dyeing process can have a substantial effect on the composition and therefore on the color of the dye, considering that several parameters have to be adjusted in the vat: the treatment time, the temperature, and the pH, namely. Additionally, sunlight can induce the bromination of the leucoforms, which, moreover, do not have the same affinity for the different textile fibers. Dyers have always been secretive to preserve the secrets of the dyeing recipe. However, the hidden process of the purple dyeing was never understood. Therefore, through the centuries, there was and still is a dedicated research to fully decipher the ancient purple industry. After a series of chemical reactions that happened for the conversion of the precursors to produce the coloring compounds, it is the bromoindigoid compounds which are the exclusive signature components of the shellfish purple, and dibromo 6,6 in dibromoindigotin being the main coloring compound. This is the marker compound of the purple that was first identified by Friedlander in 1909 after processing the hypobranchial glands of Brandaris. Coming to our purple pigment from Triada, acquiring micro Raman spectra on particles of the pigment, the 6,6 dibromoindigotin, the main chromophore compound, has been identified. Raman spectra present a perfect match with the characteristic vibrational bands of dibromoindigotin in both position and relative intensity. In addition, calcite with its characteristic vibrational band at 1085 is also identified in the composition of the sample. A few particles from the pigment sample were prepared in KBR pellet and measured with FTIR in transmission mode. The FTIR spectra, in the FTIR spectra, the well-resolved bands at 1475, 1080, 860, 711, and 700 match perfectly the respective characteristic bands of aragonite. The secondary maxima at 1420 and 875 attest the presence also of calcite in the composition of the purple pigment. So according to the FTIR data, aragonite and calcite are both present in the inorganic substrate of the pigment. The characteristic clear longitudinal crystals of aragonite are also visible under microscope in the mass of the purple pigment from Triada. While in the Raman spectra all the vibrational bands of dibromoid nicotine are resolved, in the FTIR spectra mainly only the more important bands of the dibromoid nicotine are, and these are barely resolved on the slope of the main broad carbonate band. Similar to the Triada pigment, a lump of purple pigment has been found at Akrotiri and extensively studied. In the micro-Raman spectra acquired on samples from the purple pigment finds, both from Akrotiri and Triada, the spectral signature of dibromoid nicotine is similarly displayed in all the acquired spectra. High-performance liquid chromatography, as we have already seen with the diode array detector, is the most efficient among the techniques used for the full analysis of the shellfish purple, as it allows the detection and identification of all the 7 indigoid components within a single chromatogram, and allows also a semi-quantitative and possibly complete quantitative results for the full characterization of the pigment. In the HPLC chromatogram of the purple pigment, apart from indirubin compound, which was not detected in the sample extract, the other 6 components of the purple have been identified. Summarizing the analytical data obtained through FTIR, micro-Raman, and HPLC analysis, we conclude that the composition of the purple pigment, similar among the finds of Triada and Akrotiri, consists of a calcium carbonate substrate to which the purple dye is adsorbed, possibly by immersion in the alkaline juice of the vat dyeing bath. The procedure corresponds to the description for preparing the pigment purpurissum by Pliny the Elder, and allows to trace the establishment of vat dyeing technology at least back to the late Bronze Age in the Aegean, rendering improbable the application of a direct primitive technique. The calcium carbonate substrate of the pigment, consisting of aragonite, calcite, and magnesium calcite, puts in evidence its shell origin and refers to the recycling of cells of any species, either food residues or debris of purple production. The lumps of mollusk purple found at Akrotiri and Triada, together with lumps of other pigments in the same context, could be intended for painting. The identification of purple pigment on murals at Akrotiri testifies its application in painting. The pigment is used selectively to render the petals of the crocus flowers, a necklace, and many details of the female garments and snoods in the wall paintings of the saffron gatherers, the procession of women with bouquets, and the adorants from the Xestitria 3 at Akrotiri. The discovery of the purple pigment at Akrotiri and Triada only suggests but cannot prove a local manufacturing. The purple pigment could be equally either locally produced or imported. However, there are several bits of evidence that suggest the existence of a murex purple dye industry in both these major urban centers at the beginning of the late Bronze Age. The use of purple in the women costumes, details in the painting, implicitly refers to a possible second or probably first application of the purple on Thera, the dyeing of textiles. Besides, textile production will have been quite a flourishing activity at the site, given the numerous loom weights found there. Coming again to Rhodes, excavations conducted since 1984 at Triada have yielded evidence of a rather frequent use of murex trunculus in the settlement, not only by their sporadic presence along with other finds associated with food consumption, but also by the large quantities of crushed shells used either for reinforcing lime plaster or for constructing a strong substrate for plastered pavements, as in the case of the polythyron in the Marcos plot. Now, in the Middle Bronze Age, a deposit of thousands of murex shells found in an open area close to a Middle Bronze Age polythyron, recently revealed during the excavation of the Atsinknoudas plot, south of the main Late Bronze Age city, provided further evidence of the early technologies and activities of the society at Triada before the Minoan expansion. Moreover, the presence of many loom weights in an area southeast of the main settlement suggests large-scale textile production, which might be connected with dyeing as well. Not surprisingly, the purplish color used for the pavement decoration of this wealthy building is not true purple. And making now a great leap forward, we come to the Hellenistic period and the ancient town of Rhodes, where agglomeration of crushed murex trunculus shells in thick layers of almost 50 centimeters near the Hellenistic fortification walls of the town of Rhodes suggests the existence of a purple dyeing workshop. The installation, excavated in the early 80s, is located outside the exterior fortification wall, which was built after the earthquake of 227 BC. The excavation occupied an area of 330 square meters. In between the so far abandoned fortification wall and the east-west ancient big sewer leading to the torrent of Rodini. The workshop was in use at least in two different phases. Better preserved is the last phases assigned to the second half of the 1st century BC until the first quarter of the 2nd century AD, on the basis of the coins found in the excavated part of the last phases. The early phases of the workshop are dated to the late Hellenistic period according to the pottery found below the cistern's floor. A well-organized system of cisterns was located at the northern part. An impressive drainage system supplied water to the cisterns, while sewer ditches were leading the waste products to the big central sewer at the south of the workshop. The depth of the cisterns was circa 1 meter 10 meters, apart from a shallow one that was of 40 centimeters. An open-air area paved with plaster was located west of the main system of cisterns. The southern part of the installation was occupied by 3 ovens, most probably for the control of the temperature in the vat dyeing bath, a rather challenging procedure which, according to Pliny, lasted 9 days. A deep well, located at the western part of the installation, supplied water to the workshop. A staircase at the northeast part of the complex was leading to an upper story, most probably used for the commercial transactions of the workshop, like the case of Anthibis in Egypt. Below the floor of the cisterns, pottery assigned to the first half until the third quarter of the 1st century BC was found. The existence of earlier cisterns within burnt soil below layers of murex shells, as well as the stratigraphy of the thick earth filling at the east side of the southern sector of the workshop, comprised of smashed murex shells, ashes and charcoal, and Hellenistic pottery suggested an earlier, at least late Hellenistic phase of the workshop. More recent excavation undertaken by Dr. Triantafylidis in 2006, southeast of the above workshop, has shown that the installation was extended to the other side of the central sphere of Rhodini. The so far evidence has shown that, apart from the maritime and trade activities, the development of several industries and of regular interrelations with other cultures, and in particular with the Eastern and Western Mediterranean, the cosmopolitan and rich Hellenistic and early Roman Island of Rhodes, similarly important and wealthy since the Middle and Late Bronze Age periods, based a significant part of its economy and prestige on the production of textiles, and notably of the expensive purple color, although our evidence and studies are still at the very beginning. I'd like to thank you for your attention and acknowledge many people who have, with whom we have worked together for many years, and the collaborators also at the Ormilia Center, where the major part of the analytical work has been done. Thank you.
Thank you very much also, both of you, and also these people there. I believe we have time for some questions or comments, if there are any. Yes, please.
I have a question about the chemistry part. Okay. I have a question about the chemistry aspect. What is the significance of the aragonite and calcite substratum, whatever you called it? Is that common among every sample of purple dye, or is it something particular in this case? And
it is necessary for the pigment, not for the dyeing procedure. This is a pigment used in painting. So in order to paint with purple, this inorganic substrate helps for the painting. It is the calcite base allows to work with.
It's something they add to the pigment to make it suitable for that application.
We believe that this calcite was used to take the color from the bath instead of a textile, to immerse in the same way that they immersed the textile in the bath to dye it. They immerse the chalk material to take the color. Here, with purple, it is a different mechanism. It is not a reaction, a chemical reaction. Purple is not like the organic dyes that need a mordant to be joined. It is not a reaction between the inorganic and organic part. That's why we say adsorption is the dye is sitting on the inorganic material, but you need this inorganic material to have the pigment workable in painting.
It's a way to make it solid, in other way, to make
it could be solid, but you cannot, with a binder, you cannot work with only the dye.
So you mean that it was used like a pigment?
Yes, in the painting, in the wall paintings.
Okay, so that makes perfect sense. But I would like to ask also that, for example, the calcite or aragonite could have been part of the substrate of the plaster itself.
No.
Which they,
No, yes, but in this case we have the pigment
the
before application.
Yes.
It is this.
Yes.
This analysis is done on the raw material. Of course, if it was a sample from the painting, calcite could come from the plaster. But in this case, is the samples from the different lumps of pigment found free from the painting. In both cases, and what is interesting is that it's exactly the same composition and color in the two cases, from Triada and Akrotiri.
Yes, so probably that it could mean that they take the waste of production, they make the calcite in order to have the material, and that's why we don't find huge amount of cells in Bronze Age. It's the recycling process.
It's for several purposes. Here, from Triada, the fact that we identify also aragonite is indicative of the provenance of the calcitic material.
Are there any other questions or comments? If not, thank you very much again.
Thank you.
So now we will return from the island of Rhodes to the island of Cyprus, actually to the site which gave the incentive for this workshop today. The next paper is again a joint paper by Maria Iakovou and Dimitra Milona. This is actually a product of the cooperation between the University of Cyprus Archaeological Research Unit and the EASTAP, East Crete Study Center. It is divided in two parts. Maria Iakovou is delivering the first part, and then Dimitra Milona will continue with the second part.
Thank you, Yorgos. As we had stated yesterday at the opening session of our meeting, the PORPHYRA Workshop is not the only, but it is certainly the most significant scientific consequence of an unexpected discovery. Close to half a ton of purple dye shells were found in a small and most likely basement room of a purpose-built complex. This 65 meters long, well-designed edifice was found on the citadel of the city-state of ancient Paphos, a citadel that had been established around 500 BC and was apparently the administrative and economic center of the Paphian polis, until its royal dynasty was exterminated by Ptolemy Soter, 200 years later, at the end of the 4th century BC. In this introductory paragraph, I have purposefully used two terms, classical citadel and royal dynasty, that require justification by means of material and textual evidence. Hence, before surrendering the podium to Dimitra, I will briefly define the archaeological context that allows us to visualize the storage of 430 kilos of crushed murex shells against the political institution of Paphos in the Cypro-classical period. As regards the royal dynasty, we are fortunate to have a treasure trove of syllabic Greek inscriptions on precious metal artifacts and on stone, stretching from the early 7th century BC to the very end of the 4th, that were issued by eponymous leaders who addressed themselves as Basilis of Paphos. In ancient Cyprus, the title of Basileus signifies the director general of an institution that is often described in the archaeological literature as a kingdom, despite the fact that the Cypriot kings themselves defined their state with the term polis. Paphos was one of the most prominent and resilient city-states of the island. Despite the fact that the extremely rich burial record allows us to follow the impressive development of Paphos since its foundation as a post-authority in the late Bronze Age, its capital center had remained largely invisible. It was assumed that it would have spread around the famous sanctuary of the Cypriot goddess, later addressed as Aphrodite. However, other than the modern village of Kouklia that spreads to the north, and the medieval manor house that was erected 100 meters to the south of the megalithic Temenos, the agricultural plots around the sanctuary contain only sections of 3 widely dispersed monuments. Thus, in 2006, in an attempt to define this elusive urban structure, we initiated the Paphos Urban Landscape Project. Less than a decade later, the success of PULP's methodology, which is based on landscape analysis with digital, primarily GIS applications and short-term exploratory excavations, led to the discovery of unknown monuments of the Cypro-classical period. The most impressive ones are concentrated on the terrace of Haji Abdullah, 1 kilometer to the east of the sanctuary. Despite the presence of a listed monument at its northeastern corner, the extensive plateau had been leveled with mechanical means and was used for the cultivation of cereals. The monument was found by a British team in the early 1950s, but was only partially excavated before its abandonment in 1955. Although its content has not been published and its ground plan is far from comprehensible, it has since been known as the Archaic Palace because of its cut stone architecture and the late Cypro-archaic and classical pottery found inside the building. However, it is not because of the so-called palace that we have identified the plateau as an administrative citadel. Rather, because of the complex we discover to the west, which, as you can see, has a different orientation. This unexpectedly well-preserved monument, with stone walls standing up to 2 meters, was constructed on the external side of a substantial peripolos, or citadel wall, and it was preserved under a dirt road that runs along the sharp edge of the cliff side. The entire edifice is sealed under collapsed building materials, plastered upper floors, stone walls, and huge roof tiles. A 2-meter deep heavy debris has to be removed before we can approach floor levels. To this day, we have excavated over 930 square meters without encountering a post-collapse disturbance. After 10 seasons of digging, our AONH ceramic specialist, Dr. Anna Georgiadou, can confirm that the earliest pottery assemblages date to the very end of the 6th century BC or the initial years of the 5th. Hence, the initial stages of the construction of the east and west complexes were part of a massive investment that could not have been undertaken by anyone other than the royal dynasty of Paphos at the very end of the Archaic period. Ceramic finds, even though spread out on the top of the terrace, confirm the absence of Roman date pottery. As regards Hellenistic pottery, with the exception of amphora fragments found in specific units, we seldom identify 2nd century BC ceramics. Apparently, in the 3rd century BC, hence not long after the Ptolemaic takeover, the plateau of Haji Abdullah lost its citadel status, and the urban nucleus of Pelepaphos shrunk around the sanctuary. By 2014, when we began identifying distinct units, we could tell from the material remains with which each one of them was distinguished that this was a specially designed complex devoted to industrial activities, processing of agricultural products like olive oil, and storage, especially of wine. Notice that at least 2 parallel retaining walls were built down the slope to contain the northern units that were equipped with drains. In 2016, the team began excavating a small internal room situated between a store of wine amphora to the south and a room with fine drains leading to a bathtub to the north. From that moment, from the moment that we had identified a thick layer of purple shells, every bucket of soil from Unit 2 was transported to the lab for water flotation. Dimitra Milona initiated the study of the shells in 2017 and has been with the project ever since. The collection of the entire content of the unit took 2 more seasons. We can therefore confirm 100% recovery of the unit's content. With a minor exception, I decided to leave in situ in the southwest corner a section of the collapsed episode that is a visual statement of the depositional event. Under this mass of stones, plastered upper floor fragments, huge roof tiles, there are still a couple of buckets of shells. The actual floor level of Unit 2 was not reached until last summer, and it gave us another surprise. The 20-centimeter thick deposit of crushed shells was lying on a floor made of finely laid out mud brick tiles. As I hand over the podium to Dimitra, I should add that last summer, in the corridor that runs along the east side of Unit 2, a sherd was discovered with a Greek syllabic inscription in black ink that lists quantities of an unidentified product. It strongly suggests the maintenance of accounts by the dynasty's administrative system. Dimitra, your turn.
Before I start giving you the details of this find, I would like to tell you how grateful I am to the volunteers and students of the University of Cyprus. You saw them earlier excavating and water floating this monstrous material. I have to tell you that they sorted much of it, and not only that, but they made it even look fun, even though I'm sure they were desperate quite often. Here is some snapshots. What follows is a preliminary report on this ongoing research project. We have sorted, counted, and recorded about half of this material. The recording of the rest was more summarily, so to speak, but the numbers I'm going to give you now are calibrated for the whole of the assemblage. I calculated that the assemblage is made up of about 50,000 shells and weighs 430 kilograms. And if we want to visualize that into something more familiar, think about 5 or 7 sacks full of crushed shells to get an idea. The assemblage can be considered pure. It's made up almost exclusively of this creature, the Exaplex trunculus shell. The 2 other purple shells of the Mediterranean, the Bolinus brandaris and the Stramonita hemastoma, are either absent or very rare. There are only 444 assorted shells other than purple shells. These, you see here, can be separated in 2 groups. The ones you see in the species you see in blue are all tiny in size, more than 1 centimeter in length. And here you see a representative sample of them. The rest, the yellow ones, are larger, and they are dominated, as you see, by this creature, the Eritrea cornea. This is a shellfish that doesn't produce any pigment, but it's very commonly found with Hexaplex trunculus in context of purple dye production. These shells have been also found broken, just like the Hexaplex shells. The assemblage also included a few fish bones, and surprisingly, most of them come from catfish. And also it included carbonized olive stones. The majority of the shells are heavily crushed, and in some of the subsamples within the assemblage, this crushing is quite extreme, and here I show you one such case. The complete shells are all very small in size, even smaller than what we saw in Chryssi yesterday, for example. Before Haji Abdullah, I thought that Chryssi had really small shells in it, but then I saw even worse. The complete shells were small, and here in this graph you see the dominant sizes. You see that quite a lot of them are really small, smaller than 1 centimeter in length, and that means a week or 2 weeks old. Most of them are between 1.5 and 2.5 centimeters in length. Larger shells were systematically crushed. I should emphasize here that the assemblage is contained within Unit 2. Outside Unit 2, in the whole excavated area, we hardly found any seashells at all. I don't think we have more than 5, and none of them is an Hexaplex shell. It appears as if large amounts of crushed purple shells were brought and deposited into Unit 2, perhaps brought in from above. The space contained almost nothing else when the shells were put there. There were 2 working platforms, you see there. There were at least 2, possibly 3 pounding stones, and a very small number of small vessels, pottery vessels. The sheer volume of the shells definitely speaks of systematic collection of purple shellfish, and this is something that can be safely linked to purple dye production. We have seen this picture at a number of sites, and the presentations today gave us even more such examples. Having said that, let's see to what extent we can relate the Unit 2 assemblage to the various aspects of purple dye industry listed in a schematic way on this slide. A purple dye workshop requires a steady and relatively sizable supply of raw materials. Purple shellfish can be gathered by a number of methods, including diving and netting, but the most efficient way is the use of baited baskets. Some of the observations I made earlier support the idea that baited baskets was indeed the method used in our case. The capture here appears to have been indiscriminate, including other carnivore species, especially the Eritrea, and even the smallest of examples, the ones that do not offer anything in terms of pigment. This would not have happened if collection was done by hand. The use of the net is, I think, too inefficient and too unreliable for the capture and processing of large amounts of shellfish. Crushing of the shells is one way to access the hypobranchial gland that produces the pigment, and this is the green spot here. Crushing is fast and efficient. The flesh was removed and processed to produce the purple dye. This type of crushing, however, does not produce such tiny fragments as the ones I showed you earlier. Apparently, another process was employed. Deliberate pounding has been suggested for the materials found at a purple dye workshop in Andriaki, a late Roman site on the coast of Lycia, and Gerhard mentioned that site earlier too. A process like this would explain not only the small size of the fragments in the Paphos assemblage, but also why we find other shells like the Eritrea crushed as well. The crushed shells were apparently accumulated somewhere near the purple dye workshop for further use. There are several archaeological examples of such accumulations. These are actually the most easily recognizable features of a purple dye workshop. Here I show you again this remarkable case, Andriaki. This material has been analyzed by Gerhard, so we can ask him about details on this find. Crushed shells from a purple dye workshop on the coast of Paphos were more probably packed in sacks or gathered in baskets, brought on site and stored in Unit 2. Georgia Tsartsidou, who has taken many phytolith samples from the complex, has identified the presence of bulrush in Unit 2, and Maria Dinu, who took wood charcoal samples, identified wood charcoal from terebinth. Both these plants are used in basket making, and the phytoliths and charcoal fragments in this space might be what is left of the containers that actually held the shells. I should tell you here that, especially in this room, the sampling was very deliberate and very targeted. We were wondering about this. Consequently, what we have in Unit 2 is a cache of homogeneous, clean, crushed purple shells that were kept for secondary use. We hypothesize that the crushed shells would have been used for the production of lime plaster, because such a use is documented from as early as the Bronze Age and all through to the Roman period, but also because the use of lime plaster is extensively manifested throughout the Haji Abdullah complex. Floors and walls were regularly plastered, and there is also a shallow basin made of plaster. Plaster samples from the walls and the floors of the complex will soon be analyzed by Marta Lorenzon to see if lime derived from marine shells was used in the plaster mix. Perhaps the crushed hexaplex in Unit 2 was stored in view of a refurbishment of the workshops, a refurbishment that never took place, probably because at the end of the 4th century or the beginning of the 3rd century, serious and dramatic events took place and activity in the industrial complex was disrupted. The location of the purple dye workshop from where the 430 kilos of crushed shells were transported to the citadel has not been identified. We cannot associate it with any of the excavated units. The process of purple dye production requires space, fuel, and proximity to the source of the shells. It leaves behind a strong foul smell and lots of waste. In and around the purple dye workshop, one would expect to find a scatter of whole and crushed shells, along with numerous objects that were used in the process. Although the excavated part of the industrial complex provide evidence for activities that required the use of fire, water, and pounding and grinding, hearths, drains, and basins were found in other units, not in Unit 2. And the actual lack of any purple shells in the complexes other than Unit 2 leaves no doubt that the production of purple dye took place elsewhere. The question is where? Geological studies undertaken by Senior Geological Officer Zomenia Zomeni in the context of her doctoral thesis have demonstrated that the coastline that now lies at some distance below the citadel and the sanctuary of ancient Paphos has undergone significant transformations due to the river silting and coastal uplift. Almost certainly, the Paleo coast would have been closer to the citadel and would have included a protected anchorage, since, after all, Paphos was founded as a gateway to the sea in the late Bronze Age. Therefore, a purple dye workshop would have existed on the coast, which coast would have been much closer to the citadel. As we come to the end of this presentation, let us have a look at this map, where I plotted all sites with evidence, all recorded sites with evidence for purple dye production from the beginning of the classical period to the Hellenistic. What we notice here is a remarkable scarcity of evidence for classical period production of purple. Classical sites with evidence for production in classical periods are the ones with red lettering. Evidence from the Haji Abdullah complex, however, confirms that the city-state of Paphos was one of the few places where purple dye was produced under royal authority towards the end of the classical period. In the story of Royal Purple by Jensen and Jensen, we are told that purple dye was associated in the East with royalty and priesthood. The evidence from ancient Paphos, where the kings had a dual authority, confirms this statement. Nicocles, as well as his predecessors of the dynasty that had established the citadel and the industrial complex on Haji Abdullah, are addressed on their syllabic inscriptions as Vasilis of Paphos, kings of Paphos, and also as priests of the Wanasa, the Cypriot goddess. Historical conclusions should be avoided in the context of preliminary reports and ongoing investigations. However, to the extent that the abandonment of Unit 2 as a post-extraction storage space for the shells can be dated to the end of the 4th century or the beginning of the 3rd, it's difficult not to associate it with the tragic death of the royal family of Nicocles in 306 BC, which was administered by Ptolemy I, and it marked the end of the autonomous poly-state of Paphos. No matter, however, how attractive this historical episode may sound, for the Palepaphos Urban Landscape Project, the most valuable conclusion is that the purple cells can be securely associated with the political economy of the city-state of Paphos. Whether the Paphian kings were using the prestigious dye just for their own garments or in order to export purple dye textiles, that remains to be seen. We thank you.
Thank you very much, Dimitra and Maria, for your presentation. I'm sure there must be some questions or comments from the audience.
The audience is exhausted.
The audience is exhausted. They have to wait for a moment. Yes, please.
Thank you. Dimitra, I think I should answer a few words because you asked me about Andriake. I have to confess I wasn't involved in the later excavation of Andriake. I only did the survey, a surface survey in 2004. Later on, an Austrian survey was extended in Andriake, but then the Austrian archaeology had been pushed out from Andriake by Nevsacevic, who excavated it then in a method I really didn't appreciate. Therefore, I got some samples, but without any documentation and therefore without any possibility to interpret something. So I have only the message from the surface and nothing else, unfortunately.
So you were not there when this excavation was done?
No. No, it had been done. It had been done in a very, very rude way, with really heavy machines. Yeah, I was quite upset.
Yes.
So thank you very much. Thank you, Mary. So we now proceed to the last paper of this session. For this we have to move to another big island, Euboea. This paper was supposed to be presented by Professor Stefan Schmid of the Humboldt University in Berlin, but unfortunately he could not make it to Cyprus this time. And instead it is going to be presented by one of Stefan's PhD students, Sophie Horacek, who is currently here within the framework of the Erasmus exchange program. So, Sophie, please. I'm sure that Stefan is watching us. We have a live streaming. So, hi, Stefan from Nicosia.
Yeah, thank you very much for the short introduction. I don't want to say much in advance. Just point out that, thanks, that I have nothing to do with the following presentation and the research. Yeah, exactly. So I'm only here as Stefan Schmid's voice, and he found out that he has to be at 2 different events on the same weekend, unfortunately. So if there are questions or comments, I would recommend or suggest that you write him an email. As you maybe saw on the last page here in the program is his email address, so please write him. Okay. A possible Hellenistic Roman purple dye installation in Eritrea, Greece. The PORPHYRA Workshop, organized by the Archaeological Research Unit of the University of Cyprus and the INSTAB, is a very welcome opportunity to reconsider some discoveries made during excavations at ancient Eritrea on the island of Rhodes in central Greece. Yeah. I just want to stop my time. Sorry. Some years ago, and we are very grateful to the organizers for having invited us to participate. Looking again into these results and finds from excavation campaigns carried out by the Swiss School of Archaeology in Greece from 1996 to 2000 makes one realize how quickly things change and have changed in the past few years in archaeology. The excavation we are dealing with had been documented in an almost completely analogous, that is, non-digital way. The visual documentation was done taking black and white pictures as well as colored slides parallel for every single take. Files and diaries were written manually on site. Planner and stratigraphies were drawn manually. Only the bigger plans were realized with the help of TotoStation and directly handled digitally. Consequently, all the other elements had to be digitized later on by one way or another. Either they were scanned or they had to be retyped on the computer post festum. Of course, this happens to a lot of excavations, but not having dealt with the material for some time, one is struck by, for instance, the oldest aspects of the pictures and so on. The Swiss school continued carrying out excavations in the immediate neighborhood of the lot that is under consideration here, and these new results are likely to influence the interpretation of the older excavation also in what regards the possible purple dye installation, as will be shown later on. The geographical position of Eritrea on the southern shore of the central part of the island of Rhodes, directly opposite the city of Oropos and only a few kilometers east of Lefkandi, can be considered as widely known, as well as the general ancient history of the site. Therefore, we shall directly proceed to the area we will be dealing with. An intense urban development at Eritrea was made possible only with the canalization of and protection from a river running north to south into the sea. This river originally formed a delta with many branches that made a dense building activity impossible. To have found and implement a solution to the problem around 700 BC can probably be considered a kind of initial spark for a real urban development. Shortly afterwards, a first city wall was built, incorporated the Acropolis in the north, as well as the seashore in the south. Due to the fact that the Eritreans did use the drained branches of the former delta in order to overbuild them with the streets and alleys of the growing settlement, Eritrea almost nowhere shows something that we could call hypodamic design. Since the city of Eritrea occupies the very small flat stretch between the hills of the hinterland and the sea, a very important communication artery linking the north to the south of the island, or Chalkis with Charistos, if you prefer, runs directly across the city, right along the foot of the Acropolis hill. This road is cut in the very center of the city by the most important north-south communication, leading from the slope of the Acropolis and the northern gymnasium to the sanctuary of Apollon Daphnephorus, across the Agora and to the sea. Therefore, the crossroad of these streets certainly was an important spot in the urban tissue of the city, and it is precisely on the spot, marked with a red circle on the plan on the left of the slide, that we shall focus. Over the years, several excavations helped to sharpen the picture of the ancient occupation at the central point of the city. Shortly after the middle of the 20th century, the Archaeological Society started excavating the spots OT 737 and OT 740. A few years later, the Swiss school started excavations on a spot that is known nowadays as the house with the mosaics, the house with the modern roofing on the picture top right. The plot immediately west of the house of the mosaics, prosaically called E/600NW, is the one we are going to have a closer look. Excavations there went on from 1996 to 2000. The latest plot excavated in that area again by the Swiss school is the Terrain Sandoz, so called after the funding institution that made its acquisition possible. Despite the urbanistic importance of the area just described, for the earlier period of the city's history, namely the geometric, archaic, classical, and at least partially Hellenistic periods, one can point out more important areas, such as the theatre just inside the Western Gate, on the upper part of the city on the left, the Agora in the center of the lower city, the harbor area, and most importantly, the sanctuary of Apollon Daphnephorus, marked here with a red circle. On the right side of the slide, we see a photograph showing the temple shortly after its excavation by Konstantinos Koroniotis above, and a picture giving its actual situation with the temple in the center of the photograph and one of several geometric apsidial buildings in the foreground. On the next slide, area E/600NW, excavated 1996 until 2000 by the Swiss school and marked in red, is shown in its immediate context, all phases mixed. The darker lines stand for the later periods, although, and in contrary to the legend of the plan on the left side, the separation between an earlier phase called here Classical Hellenistic and a later one called Roman is not that clear, at least as long as one sticks with the denomination of the phases. In any case, one is struck by the density and also by the importance of the later buildings, at least in the cases where we know their function. Combined with the evidence from other areas of the city, one can conclude that the area we are looking at was one of the more important in the later phases of the city's history. This area not only shows important building activities, we observe equally new features that likely changed the general designation and probably also the status of this area within the city. Combining the evidence from the different excavations, we can dress a general picture of the area. While building activities can be traced back to the geometric period, we shall focus here on the later phases. A very important and well-known phase, not only for our area but for the city in general, is the Classical period, more specifically the 4th century BC. This is also the date of the well-known House of the Mosaics, indicated on the plan by the two red arrows. We are dealing here with a typical peristyle type house, showing the public area with a peristyle and several andrones that were decorated with beautiful floor mosaics, and the private part of the house with an interior courtyard, but without columns side by side, without an upper level. Good parallels can be quoted from northern Greece, especially from Pella and other areas. Similar houses were found in other areas of Eritrea, including the immediate neighborhood. However, on the plan on the left of the slide, the 4th century BC and the Hellenistic period are indicated together with blue lines considerably blurring the picture. While most of the other buildings do indeed belong to the late Classical period, the blue structures in area E/600 NW date to the Hellenistic period. The next slide shows some impressions from the Andrones of the house with the mosaics, including a modern reconstruction drawing as well as a typical drinking vessel found there. Clearly, we can reckon the presence of a well-set elite in the city, not only but also because the spatial organization of the house quite well corresponds to the description of the house of Menedomes of Eritrea as it is given by Diogenes Laertius. While such important and lavishly decorated houses were built just next door, the area marked in red here was open space with no buildings standing there. Again, please keep in mind that the blue colors on the plan on the left of the slide does indicate the classical and the Hellenistic period together. If we would indicate the 4th century BC alone, the area E/600 NW would be empty. The only structure found there dating to the classical or very early Hellenistic period was a well, built with huge terracotta segments dug into the street at the spot indicated by the red arrow. The well measured 120 centimeters in diameter and was 5 meters deep. It was completely filled with pottery and other material of the late Classical period. Similar material was found all over the spot, obviously used in order to bulldoze the area. On the bottom of the well, a coin hoard was found consisting of 354 coins, most of them in silver. The latest coin was a silver tetradrachmon of the Seleucid king Antiochus I, reigned 281 to 261 BC. In all likelihood, and without giving further details here, the hiding of the coins as well as the filling of the well have to be seen in the context of the Chremonidian War 267 to 261 BC. The house of the mosaics and other similar buildings obviously were destroyed during the violent fighting. After the destruction of the late classical houses in the immediate neighborhood, the area of E/600 NW was occupied with buildings on its turn. However, these were concentrated on the stretch south of the east-west street. The area to the north of the street seems to have remained open without buildings. The Hellenistic buildings in our area do show various features that could indicate their function as houses, quite similar in type to the ones of the preceding classical period. The walls were built in a similar technique, covered with plaster and according to the scattered finds of carefully painted fragments, at least in some cases showing wall paintings. The floors of the more important rooms seem to have been covered with pebble mosaics. The scanty remains of the mosaics themselves, as well as the very partially preserved foundations, indicate the presence of decorated andrones, similar to the ones of the classical houses. Nevertheless, not a single room of the buildings belonging to the Hellenistic period had a built floor preserved. The best preserved example is shown on top of the left slide. One can clearly see a small part of the foundation for the floor, but not the floor itself, who must have reached the lower part of the horizontal line formed by the lower end of the wall plaster. The material culture from the layers belonging to the Hellenistic phase show the typical picture of black, brown, and red slip pottery, lamps, etc. The considerable percentage of red slip pottery, the shape of the ugentaria, and the presence of long petal mold-made bowls, as shown on the slides, indicate a use of these installations well into the later parts of the Hellenistic period. The end of this Hellenistic building phase must have been a violent one. On several occasions we found massive layers of burnt remains and ashes. Since these were more important and thicker outside the buildings, one can imagine that the buildings were cleaned from the destruction debris at a specific moment and the remains dumped outside the buildings on the street. This is shown on the top photographs on the right of the slide, clearly featuring the layers of ashes and burnt material, the red arrows. The two T-graphies were dug into the streets at the spots indicated in orange color on the plan top left. Within the destruction debris, important quantities of late Hellenistic pottery were found, and more importantly, a silver coin of the New Attic type struck in Athens under Sulla. This, together with a lead sling bullet shown above the coin, indicates that the destruction has to be related with Eritrea's conquest by the Roman army under Sulla during the First Mithridatic War, 88 to 86 BC. It is to these Hellenistic buildings that the chronological earliest important discoveries of murex shells seem to be related. The room indicated here in red color had the biggest part of its surface covered with murex shells, most of them crushed. Several points indicate a Hellenistic date rather than a Roman one for these findings, one of them being the element in the red oval. Excuse me. If we widen the neckline of the picture a little bit, we can distinguish two walls belonging to the Roman period on a higher level. These meet in a right angle in the top left corner of the picture. On a lower level, there is one wall of the Hellenistic period still showing the characteristic plastered interior side. The layer on which the crushed murex were deposited does perfectly meet the lower line of the wall plaster of that Hellenistic wall, hence indicating a Hellenistic date of that layer as well. If this is correct, we have to reckon a floor level of beaten earth in this room. The later date of the walls on the higher level is further confirmed by a fragment of what is likely to be a Hellenistic statue of a draped woman that was used for the foundations of one of the walls, the red oval. That murex shells were present on the site before the construction of the Roman walls is further confirmed by a selection of completely preserved specimens that were found when dismantling the Roman wall with a Hellenistic statue fragment. These shells were literally built into the wall. Similar layers of crushed murex were found in other rooms as well, but not in such big quantities. Bottom right. Besides the layers of crushed murex shells, on several spots we came across small assemblages of completely preserved ones, such as those illustrated on top left of the slide. Both categories of the typical purple shells are present within our material, Murex brandaris on the left of the picture and Murex trunculus on the right. Of course, one can imagine other uses of murex than the production of purple dye. In the first place comes a culinary use, since we know that they were indeed consumed in antiquity. However, in order to extract the animal from the shell, one does not need to crush it into such small fragments as we found. We can indeed reckon textile-related activities within the Hellenistic buildings in area E/600 NW. This is indicated by an important number of loom weights from the Hellenistic strata, a few of them shown on the slide here. Pardon. In some cases, they bear imprints of coins or seals. The striding Athena on top right of the slide has an excellent parallel on an intaglio that was sold on the art market some years ago. However, the quantity of loom weight from our excavation is probably too small for serious claiming a kind of professional textile-related activities to which we could add purple dyeing activities, indicated by the layers of crushed murex. The loom weights rather belong to normal household-related textile activities. Also, they were not the only activities that the people using the area in the Hellenistic period carried out, as may be indicated with fragments of beehives on the bottom right of the slide. Further evidence for purple dyeing activities may come from two rather substantial basins. Basin A is situated in central sector of the northern part of a building along the east-west street. The floor is constructed using fragmented roof tiles aligned vertically. Both the floor and the walls are covered with thick layers of hydraulic mortar. Most interestingly are a small rectangular depression in the center of the basin, entirely covered with hydraulic plaster as well, and a kind of small bench just behind the rectangular depression. As can be shown by the massive lumps of hydraulic mortar across its feet, the bench too belonged to the basin. Furthermore, on one side of the bench, a strange row of signs is carved. Their meaning remains unclear so far, and we would be happy for any suggestions. This basin is built directly adjacent to a massive stone-built well of the Hellenistic period, and the basin was supplied with water directly from the well. A very similar construction, Basin B, was partially excavated belonging to the next building further to the west. The floor is identical, but the walls do show less evidence of hydraulic mortar. Since for the construction of both basins, no new walls were built, but they were directly constructed into the Hellenistic walls. A precise date for their construction is difficult to establish. Floors of vertically aligned tiles could already belong to the late Hellenistic period. However, the floor level of both basins is considerably higher than the levels we know from the Hellenistic building phase. This could speak in favor of dating the basins to the Roman period. Such basins could correspond to a certain extent to dyeing installations of fulonicae, as we know them from Roman cities such as Pompeii. They usually show a series of bigger basins combined with some smaller vats, as indicated by the drawing on the bottom left. Although at Eritrea we do not have found smaller vats so far, at least not in this excavation, one could ask whether the small depressions in Basin A could have served similar purposes. Further, the strange holes in Basin B might indicate the former emplacement of vats made of wood or metal. We do, however, realize that this is highly speculative. When thinking in such direction, we could likely localize most production steps for tanning and or dyeing as we know them, not only from the archaeological record, but also from Roman wall paintings, such as the ones shown here. The picture on the right is especially interesting since it shows the exposure of textiles for whatsoever purpose. One has to keep in mind that textile dye dyed with real purple color extracted from murex shells have to be exposed to the light in order to allow the photomechanical reaction that leads to the purple color. As mentioned previously, the area north of the east-west street in E/600 and W never showed substantial buildings and could have offered enough space for exposing textiles to the daylight. The general aspect of traditional tanning and dyeing industry has not changed much since antiquity, as may be shown with these pictures from present-day Morocco. As for ancient Eritrea and neighboring areas, there are quite some indications for the presence of purple dye activities. A good example is a passage by Philostratos, Life of Apollonius 1:24-2. Where he describes the Eritreans Alexander the Great met in Persia. They had been carried away from their hometown by the Persians after the conquest of Eritrea in 490 BC, and despite the fact that for 150 years now they had been living in the midst of the Iranian highlands, far away from the sea, they still used elements from their former life in Eritrea on their tombstones. Philostratus says, "And there were ships engraved on the tombstones, to show that the various individuals had lived in Iberia and engaged either in seafaring trade or in that of purple as sailors or as dyers." Although modern philologists agree that the reference Philostratus gives for his account, a certain Damis, is fictional, the account had to be real in order to sound credible to his reader. Hence, the fact that Eritreans did engage in purple dyeing must have been credible. In the end, we do have some evidence for purple dyeing activities in our area in the center of Eritrea, but so far, no absolute proof. In the meantime, we thank you for your attention.
Thank you very much, Sophie. So there will be no questions for Sophie, but if you have any questions, I'm sure you can write directly to Professor Stefan Schmidt. Yes, of course.
I wanted to ask Maria and Dimitra retrospectively. I would assume that most of the papers that are presented or have been presented, the excavators assume that when Murex shells are found, wherever they are found, that the remains of some sort of elaboration that was taking place at the very spot. You presented a case, you assume they were transported from somewhere else in a secondary use. Why is that? I missed that on the paper, or I don't remember it very well.
We think that the shells came from elsewhere, and that the process of producing the dye was not taking place in that particular spot because we don't have some of the basic elements that one would expect to find in a production site. And I think the strongest argument is that there is not a single purple shell fragment outside that very specific restricted space of Unit 2. It is very contained, unusually so. I mean, you can ask, I still cannot believe it, that there is nothing else around it. It's very strange. Yes. Yes, the moral of the story is that interpretation has to follow very rigorous contextual deliberation first. It's all a matter of context, not so much a matter of the material, because today we saw convincing cases of purple dye production where the actual remains of the cells were not that many, but the context made the story very convincing.
We don't have the material remains for the episode of the production. On the other hand, the fact that we have a first floor looks as if they were placed down the hatch. Otherwise, they would have somehow spilled out into the corridors. The circulation corridor passes right to the east of the unit, and there isn't a single piece of a murex shell outside.
I have a comment on Sophie's speech concerning that those completely preserved murex shells you showed us. As far as I could see, they had this only had been Bolinos shells, yeah? And this reminds me very much on the filling of a sewer-like ditch in archaic classic Aegean that was also totally filled with complete Bolinos shells. Maybe in particular that species had been used as a special building material. If some special kind of draining or what else was necessary. Because, Sophia, you said those shells had been built just in the wall, isn't it? So this is just a... Genau, Bronze Age Styropor. What else? Thank you.